Good morning, everyone. My name is Uma. I am from CSBS department. Today, I am going to explain about the course syllabus of operating system. So, first of all, coming to the syllabus. This is R22 regulation course. Coming to the unit 1, we have introduction about operating system, the basic concepts of operating systems, and what are the generations of operating systems, types of operating systems, what kind of services provided by the operating systems, and what are the interrupt handling, and the concept of system calls. And after that, we have two types of architectures here. One is operating system architecture, and second one is computer architecture. And after that, the concept of virtual machines are there, and views concept is there. In this views concept, totally we are going to learn about three kinds of views. One is resource manager, and second one is process view, and the third one, that is hierarchical view. And after that, there is a second chapter in the first unit, that is process. So after that, this second chapter, first of all, we have to know that what is the definition of a process, and after that, process relationships we have, and how many states of a processes we have, and the transitions between the each and every process. And after that, there is a life cycle of process states from starting to the ending. And after that, process control block is there, PCB, and the importance of PCB is also there. And in the second chapter, the last topic is context switching. And after that, second chapter, we have a third chapter. That chapter is threading. So after that, the threading introduction, first of all, we have to know that what is the definition of a thread, and what are the various states in that, and what are the main benefits of a threads we are using, and types of threads, how many types of threads are there, and after that, concept of multi-threading concept. So this is a first unit syllabus. In these three chapters, mainly we are going to focus on the basic part of the operating system, and after that, the minimum kinds of the deepest concepts, and after that, threading, how the thread concept is happening, and how the threads are going to use in a real-time environment of operating systems. And coming to the second chapter, that is a second unit we have. So in the first unit itself, we know that what is a process life cycle, process states, and the transitions, how that process control block will make a major role in the process, and after that, the concept of context switching. Now in this unit, we are going to concentrate only on the process scheduling, how we are going to schedule each and every process, and what are the main fundamental scheduling objectives we have, and how many types of schedulers are there, and after that, scheduling criteria. Before that scheduling, we need to implement a criteria for the scheduling process, and how we are going to use that CPU in a better utilization, and what is the concept of throughput, what is the definition portion of turnaround time, and after that, what is waiting time and response time. So these are the main objectives of process scheduling. And before scheduling the process, we need to calculate each and every term of this scheduling criteria. And after that, the very important topic in the second unit, that is scheduling algorithms. So in the scheduling algorithms, first we need to know that what is preemptive and what is non-preemptive scheduling techniques, and what is the difference between them. And after that, we have three kinds of scheduling algorithms. One is FCFS, second one is SJF, shortest job first, round robin scheduling algorithms. So these three are very, very important. Apart from these three, we have another one is also there, the fourth one, that is a priority scheduling algorithm. So these are the major scheduling algorithms. So we are going to discuss in the second unit. And after that, we have some multi-processor scheduling algorithms. Why? Because in the first unit itself, we have a topic that is single processor systems and multi-processor systems. That means the system contains one processor in that, and in somehow systems we have multi-processors also. So for single processor systems, we have to schedule the CPU, and in multi-processor systems also we are going to schedule the CPU scheduling criteria in a different way. So in multi-process scheduling algorithms also, we are going to schedule the CPU in a different approach. And after that, we have a real-time scheduling algorithms. These two are the real-time scheduling algorithms. One is rate monotonic scheduling algorithm, and second one, that is EDF, early detection first algorithm. These two are the real-time scheduling algorithms. So after that, these two chapters, that is process scheduling, and after that scheduling algorithms. In the second unit, we have a third chapter, that is inter-process communication. So in this chapter, we are going to synchronize each and every processes, and what kind of communication we are going to provide for the processes. So this chapter is completely a synchronization based chapter. In this, we are going to concentrate initially at concurrent processes, and what are the precedence graph we have, and how many precedence graphs are there, and what is the critical section. Very, very important topic in this chapter, that is critical section. So the definition portion of critical section, and what are the race conditions, what kind of problems we are going to face here, and what is the mutual exclusion, and after that, what kind of hardware solutions we are going to providing for synchronization issues, what are semaphores in that, and is there any alternatives for semaphores. And after that, in this concept also, the another alternative approach for a semaphore is the monitors. We know that here is the monitor concept. And after that, the classical synchronization problems, the Peterson solution, what type of solution provided by the Petersons, and the classical synchronization problems we have. First one is producer consumer problem, and after that, event counters, what kind of invoking counters we have at each and every communication patterns. And after that, message passing, what is that message passing, and classical inter-process communication problems are there somewhat. Those are readers and writers problems. So by using semaphores, how we are going to providing the solution for readers and writers problem, at the same time producer and consumer problem also. And after that, we have dining philosophers problem, and the last one, that is barbershop problem. So these are some kind of classical synchronization problems, and by using semaphores and in some conditions by using some monitors, we are going to providing some solutions for this classical synchronization problems in the second unit. So in the second unit, we are mainly concentrating on the CPU scheduling, and after that, inter-process communication, that is the synchronization between each and every process. And coming to the third unit of syllabus. So in this third unit syllabus, the first topic is deadlock. So this is our repeated continuous problem in the operating system. Here we are going to have three kinds of questions in the deadlock. How we are getting the deadlock, why we are getting the deadlock, how we are going to providing the solution for the deadlock. So in this basic deadlock chapter, what is the definition first, and what necessary and sufficient conditions for having the deadlock, and there is a strategies here. We are follow some strategies here. What are that deadlock prevention techniques we have, deadlock avoidance techniques we have. In that deadlock avoidance, we have a Banker's algorithm, deadlock detection and recovery. So this deadlock chapter is very, very important in the exam point of view, and we have some strategies. At the same time, we have some algorithms too. So in that very, very important algorithm, algorithm, that is Banker's algorithm. And after that, in this unit 3 second chapter, concurrent programming is there. So in this concurrent programming, already in the second unit itself, once we learn that critical section. So in this in the concurrent programming also we have the topic critical region, and what type of conditional critical regions we have. And again in this unit also we are going to learn what is monitors, and what are the concurrent languages nowadays we are using, and the communicating sequential process CSP. So how the sequential communications, why? Because in the concurrent programming, the name itself says that we are going to execute the multiple processes at a time, concurrently, parallelly we are going to executing multiple processes, so that the communication between the processes is very, very important. Why? Because we are not allowing any multiple processes at a time. Why? Because we are getting some issues, those are executing issues we have. Why? There is a reason no two processes merge at the execution time. Why? That leads to some inappropriate results. So we are providing some communicating sequential process, that is CSP is a technique actually, without any restrictions, without any conditions, we are going to execute the multiple processes parallelly. And here also in the concurrent programming, deadlocks, again we have the deadlocks topic. In this also some prevention techniques we are going to follow, avoidance techniques we are going to follow, detection and recovery. So in the first chapter itself we have the deadlock topic, and in the second concurrent programming also we have the deadlock topic, but both the conditions are somewhat similar. 99% both the topics are similar. At 1% only we are going to learn that deadlocks in a concurrent programming in a little bit a different way. And the third chapter in the third unit, that is memory management, very, very important one. Why? Because operating system, one of the main service of operating system is memory management. For each and every process, the memory allocation is very, very important. So before the execution of process only, we have to allocate some memory to each and every process. So how that memory is managed by the operating system is very important. So the basic concept of memory management, we in this we know that we have two kinds of memories. Main memory is there, secondary memory is there, some kind of other memory saved devices are there, hard disk, pen drives, etc. So how that memory management will be very helpful in the case of operating systems. And after that we have a logical and physical address maps. First of all, before explaining this topic, we have to know that what is the logical and physical address, the difference between the logical and physical addresses, how the data is going to store in the logical and physical addresses, and after that the memory allocations. So in this concept, in the memory allocations, we have two kinds of memory allocations are there: contiguous memory allocations and non-contiguous memory allocations. So in contiguous memory allocations and non-contiguous memory allocations, fixed and variable partitions are there. So after explaining this fixed and variable partitions, we have another important topic, that is internal and external fragmentations. So actually, these two are the problems we are facing in the memory management. After allocations, after allocating some kind of memory to each and every processor, sometimes we may get some space internally, sometimes we may get space externally. So that space management is very, very important, and how that operating system will manage the memory management in internal and external fragmentation view. And after that we have a topic, that is compaction. So this is third unit syllabus. In this three chapters, deadlocks, concurrent programming, memory management. So all these three concepts are, first two are somewhat related, and third one, that is memory management, is somewhat different. That means this is another service provided by the operating system. Coming to the fourth one, in this fourth unit, we are going to completely concentrate on the input-output hardware and input-output devices. Why? Because the resource management is also very, very important in the operating system. How we are going to allocate the resources to each and every user. At the same time, the process also. So in this IO hardware, we have device drivers, direct memory access topic is there, what are the basic principles of input output devices. So this is the first chapter. And next one, we have a file management topic is also there. In this file management, what is the concept of a file? First of all, we have to know that the definition of a file, and what are the basic concepts of file, what kind of access methods we are going to use for fetching the files from the database, and file types, how many types of files are there, what kind of operations we have, file operations, and directory structures. What are the directory structures, how we are going to implement the directory structures, how to retrieve the data from the directory structures. So all these we are going to learn here. And file system structures, allocation methods. We have three kinds of allocation methods in this unit: contiguous memory allocations, linked allocations, indexed allocations. So these are some allocation methods for each and every process and each and every user. We are going to allocate some storages here. Then free space management. If we left with any space managements in the disk, so how we are going to operate that free space management. And here also we have three kinds of techniques we are using. That is, one is bit vector, second one is linked list, a third one is grouping. That means if space is available in the disk, in the memory, so that will also handled by the operating system in this three approaches. And after that we have a directory implementation. So why? Because if you want to store any data, any kind of file spaces, so we need to implement the directories, so that directories saves some space, some memory. So here also we are using two kinds of directory implementation. One is linear list implementation is there, second one hash table is there. And after that, how that allocation methods of file management, how it is efficient, and how it is what is the better performance of file management will be explained in this chapter. So these are the main, and from this unit 4, the main important topics is file system structure, allocation methods, and directory implementations are very, very important in the exam point of view from the 4th unit. And this is somewhat a simple unit. Completely we have theory, and if we learn the little bit strategies, free space management strategies, allocation methods, and implementation. So this is basically a scoring unit of operating systems. And in this also, in this file management, after that we have after memory management and file management, we have another topic is there, but in this syllabus the topic is not included, but in the lab syllabus the topic is there, that is page replacement algorithms. So after allocating some kind of memory managements to each and every process, so how that page replacement techniques are used. So in that page replacement algorithms also we have 3-4 algorithms are there, page replacement algorithms. Those are very, very important. So in that page replacement algorithms, so how the data, how that memory, or how we are going to allocating for each and every division of main memory, at the same time the division of secondary memory, and how that will be how that will be filtered with the pages and some kind of frames, and we are using some techniques for the page replacements. So it leads to, after page replacement algorithms, the final agenda of using that page replacement, we are going to reducing the burden of operating system. Every time we went to the main memory and fetching some information, every time we are checking whether that page is existed in the main memory or not. That is so much burden will be on the operating system. So we are going to reducing that burden of operating system complexity. We are using page replacement algorithms. So in that topic also we are going to explain in the after that memory management and allocation and file management also. And coming to the last unit of operating system, so this is disk management, how the disk is implemented, and after that implementations and the structure of disk management, we have a disk scheduling algorithms also there. Here same as FCFS and SSTF is there, scan scheduling algorithms are there, CSCAN scheduling algorithms systems are there, disk reliability, in what way we are going to formatting the disk, what is boot block, and what are the bad blocks, and some kind of techniques we are going to learn in this unit 5. And this is also a scoring unit. Damn sure we got the questions from this disk management. And in the last we have a case studies on the operating system. We know that we have multiple types of operating systems are there. So in this case studies we have Unix operating system, how that file systems we have, shell case study we are going to learn, filters we are going to learn, shell programming, we are going to learn about the case study on the shell programming with the standards with input output, and Unix system call. So these are some real-time case studies we are going to learn. And all these topics, there is a prescribed textbook for 22 regulation, operating system concept essentials, Abraham and Peter Galvin and Greg and Gagne. So these are the authors. And in this textbook we have all the topics, and we are going they cover all the topics in the syllabus. So briefly in the unit 1, the main objectives and operating system, everything, what is process and what is the main components of operating system, the architectures, everything in the unit 1. In the unit 2, process scheduling, we are concentrating on scheduling algorithms and inter-process communication. In the unit 3, deadlocks, concurrent programming and memory management we are going to learn. And unit 4, IO hardwares and file management and page replacement algorithms are also there. In the unit 5, disk management and some kind of case studies we have. So this is the syllabus we are going to discuss in the further classes. And this is a very important core subject of for second year students. Why? Because from this operating system, any kind of competitive exams, we may get at least 3 to 4 questions from this operating system. That much important subject this is, and it is a very core subject, must and should learning subject. This is operating system.
Like, share and subscribe. Hit the bell icon for more updates.